All right, this is the third video, Unit 9, 3. It's really just Section 9, 3, and then Unit 10 for circles. So the number 1 here says find, or number 22 says find the center and the radius for each equation of a circle. So our equation for a circle was x minus h squared plus y minus k squared, quantity squared, equals the radius squared. So again, this says x minus h. That's the same as x minus -5. That's how you get a plus, is if you do x minus -5. So h here is going to be -5. And then y minus k, so 6 is k, so the center should be -5, 6. Okay. And the radius, this is r squared here. So r squared is 121. So if you take the square root of both sides, you get the radius is 11. Okay. So that's 22. 23, they're giving us a circle. So the center of that circle is, let's see, -4, -2. And then to find the radius, we can pick a direction here. Let's go right. This is 1, 2, 3. So the radius of the circle is 3. Once you have the center of the circle and the radius, you can write your equation. So x minus -4 becomes x plus 4 squared. And then y minus 2 becomes, or sorry, y minus -2 becomes y plus 2 squared. And then r is 3, so r squared is going to be 3 squared, which is 9. So there's the equation for this circle. Number 24. Write the equation for each circle with the given radius and center. So we have a radius of 2, center of 4, -3. That's basically exactly what we did for 23, except we don't have a graph. They're just giving it to us written. All right, so we're going to do x minus 4 squared plus, and then y minus -3 becomes y plus 3 squared. And then the radius is 2, so r squared is going to be 2 times 2, which is 4. And there's our equation. 25 wants us to graph. So again, we need the center and the radius. So our center should be 5, 1. Right, so it's x minus 5, so h is 5, and then y minus k, so k is 1, so h comma k is our center. And then r squared equals 49. Take the square root of both sides, that means r is going to be 7. The square root of 49 is 7. So I'm going to graph here. Let's say this is the point 0, 0. So we have our y-axis here. And we have our x-axis here. The center of our circle is 5, 1. So I'm going to go over 5 and up 1. Maybe this isn't a good idea. Let's do this. Let's see, we need a radius of 7, right? Let's make this the point 5, 1. So let's make this right here 0, 0. So let's make this our x-axis. And let's make this our y-axis. We need a little bit graph. This graph on here is too small. That's my fault because I made this review. So 1, 2, 3, 4, 5, and then. Okay, so there's the 0.51. There's the center. So to make the circle, we're going to go 1, 2, 3, 4, 5, 6, 7 units up. We're going to go 1, 2, 3, 4, 5, 6, 7 units to the right. 1, 2, 3, 4, 5, 6, 7 units down. And then 1, 2, 3, 4, 5, 6, 7 units to the left. And then we're simply going to draw in the rest of our points. And that would be our circle. All right, just the graph wasn't big enough, and that's my fault. All right, 26. The diameter is 24. That means the radius of our circle is 12, right? The diameter is double the radius, or the radius is half the diameter. We want to find the length of arc AD, so we're using the arc length formula. So arc length equals x over 360 times 2 pi r. So we're solving for the arc length. We know our, in this right here, we know our angle measure, central angle 60. That means the measure of that arc is 60. So that's 60 over 360 times 2 times pi, and the radius we said was 12. 60 over 360 is 1/6. 2 times 12 will be 24. And then 1/6 of 24 is going to give us 4. And then we have the pi left. So our arc length should be 4 pi centimeters long. Okay, and that's approximately 12.76. I think, right? 4 pi, 12.56. So about 12.57, 12.6 centimeters long. All right. Number 27 is also arc length. Except this time they're giving us the arc length and we're finding the radius. So we're using that same equation as last time. So delete all this. We're going to use that same equation. Okay, this time they're giving us arc length, which is 5 pi. So we're going to substitute in 5 pi for arc length. And then the arc measure they're giving us for arc EF, the central angle is 30 degrees. That means the measure of the arc is also 30 degrees. Okay, times 2 times pi times the radius. All right, we can divide both sides by pi. Right, and so that'll cancel it out on both sides if we divide both sides by pi. 30 times 2 is going to give us 60. So we have 60 over 360 times r, right? If we combine the 30 and the 2, this is 60, 30 times 2. 60 divided by 360 is 1/6. So we can reduce that to 1/6 times the radius. And then from there, we can multiply both sides by 6. And that gives us 30 equals the radius. 30 inches is our units. So those are the two on arc length. The last two here are on sector area. So our sector area equation is very similar, x over 360, except instead of multiplying by the circumference, we're going to multiply by the area. It's a fraction of the total area of the circle. The total area of the circle is found by doing pi r squared, so we have some fraction times pi r squared. Okay, the area, find the area of a sector whose central angle is 120. So we have 120 over 360 times pi times 12 squared. Well, 120 over 360 is a third. So we're going to have sector area equals 1/3. And then 12 squared is 144. And then we have pi. And then we can do 1/3 of 144 should be 48. So our sector area is going to be 48 times pi units squared. 0.9 is the same here, except instead of solving for sector area, we're solving for the radius in that same equation. So let's scroll down and erase this. Okay, so this time we're going to substitute in the sector area of 5 pi and the arc measure of 72 times pi times the radius squared. All right, we can divide both sides by pi. And that gives us 5 equals 72 divided by 360. That's 1/5 times r squared. And we can now multiply both sides by 5. And that gives us 25 equals r squared. And if you take the square root of both sides, you end up with a radius of 5. So your answer should be 5 units long. And that is it for the circles review.